Welcome to Mr. Greenstein's Geometry, and we're now in Chapter 7.4. We're going to be looking at properties of special parallelograms. We've been looking at general parallelograms, and now we're going to look at two in particular that are special, and they are the rectangle and the rhombus. The thing that's special about the rectangle is that all the internal angles are 90 degrees. For the rhombus, what's special about it are the sides are all congruent. So these are parallelograms, since the sides are parallel to each other, but they're special in each case. What I'd like you to do is to create a Venn diagram of the four words at the bottom. Parallelograms are the general case, and then there are specific kind of parallelograms, rectangles, rhombuses, and squares. Create a Venn diagram showing how they are connected. Pause right now, and then we'll rejoin back in a moment. Welcome back. The parallelogram, since it is the most general, it is going to be the outermost layer. Every parallelogram is a quadrilateral, but very special quadrilaterals are parallelograms, and that's when they have opposite parallel sides. Rhombuses, every rhombus is a parallelogram. They all are. That's because the opposite sides are congruent. Rectangles are also all parallelograms because their opposite angles are congruent. It turns out that rectangles and rhombuses can share, and the only time that they share when you have all 90-degree angles and all the sides the same length, that is where the squares come in. So this is the Venn diagram that you should have come up with just a moment ago. Let's talk about some theorems. The rhombus diagonals theorem says, and this is a biconditional, and we know this is a biconditional because we have the words if and only if. A parallelogram is a rhombus if and only if its diagonals are perpendicular. That means we could say it this way. If a parallelogram is a rhombus, then its diagonals are perpendicular. Or we could say, if a quadrilateral's diagonals are perpendicular, then it is a rhombus. So you can do it either way. The next theorem is the rhombus's opposite angles theorem. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So notice that we have these angles over here that are bisected and bisected over here. We have these angles are bisected in the same thing over here. Now don't get these confused that all the angles are going to be congruent. That is not true. The opposite angles are getting bisected, and there's a lot of congruent angles here. In fact, there's 4. But these angles are not congruent to these angles. Do not confuse those two. The next theorem is the rectangle's diagonal theorem. If a rectangle or parallelogram is a rectangle if and only if its diagonals are congruent. So if you find that you have a quadrilateral with congruent diagonals, then you have a rectangle. Or if you have a rectangle, then you know that the diagonals will be congruent. Here we're going to solve a problem using all of those theorems that we have. We know that we have a rhombus, and if we have a rhombus, that means that the opposite angles are going to be bisected by the diagonals. Each one of these is going to be bisected. And we also know that the two diagonals are perpendicular to each other. Well, that helps us right away, because if they're perpendicular to each other, then each one of these angles equals 90 degrees. And we can set this equal to 90 degrees and solve for A. Once we have that, then we can solve for this angle here. We also know that a rhombus has equal length sides. So then that means that this side has to be congruent to this side. So we can just set those two equal to each other and then solve for TV. So we should be able to solve for both of these values. And you can pause and solve that on your own. In this next problem, we have the square EFGH, but we want to show that the diagonals are perpendicular and that they bisect each other. So we're trying to show two things, perpendicular, and we want to show that they bisect. Perpendicular, the way that we show that is we would use slope. And the slope that we would want to use is the slope from F to H, and the slope from E to G. Because if we show the slope from here to here, let's actually draw a line, and then a slope from here to here, we could show that they're perpendicular to each other. Another thing that we want to show is that they bisect each other, and the way that you would figure that out is use midpoint. So you would find the midpoint from F to H, and you would find the midpoint from E to G. And once you have those two, they should be the exact same point. If they're perpendicular slopes and they have the same midpoint, then you should have, then this should be a square. You're going to use that same technique with this problem, A, B, C, and D, and you should plot it out and then use the same techniques with the slopes and the midpoints to figure out whether it's a rectangle, a rhombus, a square, or any combination of those three. And then we'll revisit these in our class tomorrow.